Now that we know how to find a first derivative, guess what? We can find multiple derivatives. On this example 5, we are going to find the third derivative. When I find a third derivative, you start off with your function. Then you take a derivative and you get the first derivative. When you take multiple derivatives, you build off the previous. So now I've got my function, I've taken a derivative. Now from here, I'm going to take the next derivative and you put 2 tick marks there. Then you can take the third derivative. Now in terms of tick marks, the 3 is as high as you go. After you go there, then you put the little number up on top. For this problem, we're just hanging out right here at the third derivative, but I just wanted you to see the notation of multiple derivatives. Okay, let's do this thing. For part A, we are taking f of x is equal to 3x cubed minus 5x plus 12. And we're going to the third derivative. The third derivative. All right? So my first derivative, I'm going to bring this 3 in front. So 3 times 3 is 9. Subtracting 1 from that would be x squared. Then I have minus 5, because remember with the x, it's just a coefficient. And then that 12 in the back is a constant. Now for the second derivative, you are going to build off of the first derivative. So you can't just randomly have a third derivative. You have to build in order to get there. Okay. So I now have 18x. And then the 5 is a constant, so it's a 0. Then my third derivative, the derivative of 18x, is just 18. Cool, right? You're literally just taking 3 derivatives. You just build off of the next one. Let's do another. Now I'm going to show you some different notation. What if I start here with y is equal to 3t plus 2t to the 10th? We're still going to go for the third derivative. All right, still the third derivative. But I'm going to do dy dt because I want you to see multiple notations. So I'm taking the derivative of y with respect to t. So there's my y, and then t is the variable, and that's what goes on the bottom. So my first derivative would be 3 plus 20 t to the 9th, right? Then to get a second derivative, you put a square next to the d and a square next to the t. So the top one has the derivative denoted by the d, and the bottom is by the variable. So then that 3, we know zeroes out, but 9 times 20 is 180 t to the 8th. And then you just keep going with that notation. So d3y over dt cubed is equal to, oh dang, what's 180 times 8? T to the 7th. Oh, that'll be a 0, 4, 6, 1,440. Check my math. Yep, that's good. So 1,440 t to the 7th. Now this one started off with such a big exponent, you could just keep going with those. But it just asked for the third, so then that's where we're going to stop. Okay? All right. Very cool. Multiple derivatives, you just keep going with it. You have to build on the next one in order for you to pull that off.